Have you ever looked up at the night sky and just wondered what stories are hidden up there? Well, tonight, we're diving into one of those stories. We're going to focus on a single, ancient city of stars to crack a huge secret, a secret about the birth of our very own Milky Way galaxy. So let's get to it. Our destination, Messier 69.
So here it is. This is Messier 69, or M69 for short. It's what's known as a globular cluster, basically a giant dense ball packed with hundreds of thousands of stars. It's located almost 30,000 light-years away from us, over in the constellation Sagittarius. And yet, at first glance, it's just this beautiful, glittery swarm of really old suns. But don't let its looks fool you. M69 is a total cosmic anomaly, and it's a clue that's helping us rewrite the story of our home galaxy.
You see, locked away inside the light from its stars is a chemical mystery. And if we can solve it, it's like having a time machine. We can look back and witness the fiery, chaotic birth of the Milky Way's core. So what can this one ancient object really tell us? Well, as it turns out, pretty much everything. Okay, this is where our cosmic detective story really begins. The central puzzle of M69, it isn't something you can just see. It's something you have to measure. We're talking about a serious anomaly in its chemistry.
Now, before we go any further, we got to get on the same page about something. When astronomers say metals, they aren't just talking about iron or gold. In astronomy, a metal is literally any element on the periodic table that isn't hydrogen or helium. These heavier elements, they get cooked up in the nuclear furnaces inside stars. And then when those stars die, especially in these huge supernova explosions, they get blasted out into space. So every generation of stars makes the universe a little more metal-rich.
So there's a really simple rule of thumb in the cosmos. The older something is, the fewer metals it should have, right? The very first star clusters were made from basically pure hydrogen and helium, super metal poor. But M69, it just completely breaks that rule. It's incredibly ancient, but it's jam-packed with heavy elements. It's metal-rich, when every sign tells us it should be metal poor.
And I'm not talking about a small difference here. M69 has more than 10 times the amount of iron compared to other clusters from that same ancient period. I mean, this is a huge chemical discrepancy. It's kind of like finding a brand new smartphone inside a sealed Egyptian tomb. It just makes no sense. It shouldn't be there.
So how can we be so sure about all this? How do astronomers read the history of an object that's so mind-bogglingly far away? Well, they have this brilliant set of forensic tools that let them dust for cosmic fingerprints and basically turn back the clock. The whole investigation is really a two-step process. Simple enough. First, you have to read the cluster's chemical fingerprint to see what it's made of. And then second, you have to nail down its age to confirm it's as old as we think it is.
So, step one, how do you get that chemical fingerprint? By looking at a star's light spectrum, just like this one. Astronomers use a technique called spectroscopy, which splits a star's light into a rainbow. See those dark dips and lines? Those are absorption lines. They form a unique chemical barcode. Each one of those dips tells us a specific element in the star's atmosphere is blocking that color of light. And those deep lines for iron? Well, that's our smoking gun.
And here it is, the hard evidence. Researchers measured the iron content and got this value. Now, I know, that number looks a little strange and scientific, but what you need to know is this. For a cluster this ancient, that number is way higher than it should be. It's the scientific proof that M69 is way richer in metals than its peers.
Okay, so the chemistry is officially weird, but how do we know it's actually old? For that, we use this absolutely incredible tool, a color magnitude diagram. What you're seeing here is a chart that plots every single star in the cluster by its brightness and its color. See, as a star cluster gets older, its biggest, brightest stars burn out first. This makes that long diagonal line of stars, the main sequence, start to peel away from the top. And the exact spot where it turns off, that's a direct measurement of the cluster's age. It's like a cosmic clock.
And the age that this cosmic clock shows for M69 it's just staggering. Roughly 14 billion years old. That makes it one of the most ancient objects we've ever found in the entire universe, formed right at the dawn of time. And, that just makes the mystery even deeper. How could something so old have so many heavy elements?
Well, the answer, it turns out, isn't really about what M69 is, but where it is. To solve this case, we have to go to the scene of the crime, the very heart of the Milky Way galaxy.
See, most globular clusters are kind of like lonely satellites orbiting way out in the galaxy's huge empty halo. But M69, it's an inner-city kid. It lives just 5,000 or 6,000 light-years from the galactic center, deep inside this crowded, chaotic region we call the galactic bulge.
And this is the crucial clue. So why does living in the bulge matter so much? Because in the early days, the galactic bulge wasn't some quiet neighborhood. No way. It was a violent, super-dense star factory. Massive stars were born, they lived fast, and they died young in these spectacular supernova explosions, just flooding the whole area with heavy elements. M69 didn't have to wait around for generations of stars to enrich it. It was born right in the middle of a metal-making party.
You know, this brings up an even bigger question. How did the bulge form in the first place? Well, scientists have two main competing ideas. One theory says the bulge was built slowly, piece by piece, as our galaxy basically ate smaller satellite galaxies. The other says it formed more naturally, when our galaxy's flat disk just became unstable and kind of buckled up in the middle.
But M69 throws another wrench into the works. This complex-looking chart shows some really strange chemical patterns inside its stars. For example, the amounts of sodium and oxygen are what we call anti-correlated, which just means where you find more of one, you find less of the other. And these specific chemical signatures, while they don't really fit neatly into either of those simple formation models, it tells us the real story is probably a lot more complicated.
All right, so we've got the anomaly, we've got the forensic tools, and we've got the clues from the scene of the crime. Let's put it all together. It's time to deliver the final verdict on this ancient cosmic mystery.
The timeline is actually pretty clear now. M69 is about 14 billion years old. We know from its chemistry that it was born in a place that was already overflowing with metals. And really, the only way both of those things can be true is if its home, the galactic bulge, formed and enriched itself with the ashes of giant stars incredibly fast, right at the very beginning of the universe.
So what's the real takeaway here? M69 isn't just another ball of stars. It's a fossil. A perfectly preserved relic from the fiery, chaotic birth of the Milky Way's core. It's telling us that the heart of our galaxy was one of the very first things to ever take shape. So let's recap our investigation real quick. The case, the mystery of the metal-rich ancient star cluster. Our clues, the chemical barcodes from spectroscopy, and that cosmic clock of the color magnitude diagram. The motive, or really the how, was its location right in the galactic bulge. And the final revelation, the heart of our galaxy formed in this brilliant, rapid flash right at the dawn of time.
And if that wasn't already enough to blow your mind, check this out. At 14 billion years old, M69 actually seems to be older than our current estimates for the age of the Milky Way galaxy as a whole. This hints that the central bulge might not just be an early part of the galaxy, it could be the actual seed from which the rest of the Milky Way grew around.
And that leaves us with one last thought. We figured all of this out just by studying one faint, kind of ordinary-looking cluster of stars. It really makes you wonder, doesn't it? If one object can completely reframe the story of our cosmic home, what other profound secrets are still out there, just hiding in plain sight,